In this video, we're going to wrap up polygons by talking about how to solve for angles in combined polygons. So just to review, remember our interior and exterior formulas for polygons. If I'm looking for the sum of the angles, it's the number of sides minus 2 times 180 for the interior, versus just 360 for the exterior. Then if I'm looking for one angle, and again, this is one angle of a regular polygon. You can only use this level if you're using regular polygons. It's n minus 2 times 180 over n and 360 over n. Now, what we want to look at is problems like this, where I'm supposed to find the length of this arc right here, knowing that, again, assuming that the angles are regular or the polygons are regular, solve for that angle. So let me just kind of talk through. We're going to do one on the interior, one on the exterior, and kind of talk through a couple of different strategies. So the first strategy I would use here is I would solve for each angle individually. All right, so let me actually grab a different color here. So let's take a look. Let's think about this as an angle, this angle right here, and then let's also think about this angle over here. So we're going to think about two different angles. So this first angle right here, hopefully we recognize is 90, but if we weren't sure where that came from, I would just do my 4 minus 2 times 180 all over 4. We should also recognize that a regular quadrilateral is a square, and that's going to come out to 90 degrees. Now, let's solve for this angle over here, okay? So I've got 90 degrees on that side. Now on here, I've got what looks like I've got 8 sides, so that's an octagon. So once again, I'm going to do my, if it's regular and I'm looking for 1, I'm going to do my 180 times 8 minus 2 all over 8, okay? And that should come out to 135. All right, so this piece is 135. So if I want the combined amount, the combined arc, if I think about it as two separate polygons, what I'm going to do is I'm going to take the 135, I'm going to add that with 90, and I get 225 as a final answer. Now, one of the keys here is, one of the places where a lot of people go wrong is they try to count all the sides and they go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they try to do something like that. But this is not a 10-sided polygon. This is an 8-sided polygon combined with a 4-sided polygon, okay? So when we're doing it, let's make sure that we just think about it as two separate polygons. All right, so we looked at the interior. Now what if I want to solve for the exterior, okay? Now this seems a little bit tricky. Now there's two ways you could handle it. One way would be to do it just like we did before. We'd solve for this angle here, we'd solve for that angle there, and then we would subtract them out of the whole amount, 360 degrees, and solve it that way. But let me show you another way that's actually a little bit easier if I'm trying to solve for an exterior angle. Let's imagine that this line is extended, okay? So I've got that line extended, and I've got two angles here. I've got this angle here and that angle there. All right, so that tells me that I've got two exterior angles. Just like we did two interior angles, we've got two exterior angles in play here. One for my octagon, and then one for my hexagon. So this one is going to be 360 divided by 8 for the exterior angle, and this one's going to be 360 divided by 6. So that comes out to 60 degrees for this exterior angle. That's 60. 360 divided by 8, that comes out to 45. So that's going to be this angle right here. And then what I'm going to do is I'm going to add these up. So 45 plus 60, I end up with 105. So if I'm dealing with exterior, I can think about it as two exterior angles. If I'm dealing with interior, I could do two interior angles. But you could also, like if we look back at this problem, if I wanted to, I could have solved for the two exterior angles and subtracted it from 360, because that's the whole way around a circle. You could also solve it that way. But just wanted to show you some of these problems. It's kind of the last thing we have to cover for polygons. Hopefully it makes sense. And that really wraps up everything else we might have to deal with polygons.